Estefania Gordilla, and this is General Chemistry 1, Interactive Advanced Concept Presentation 2. So today we're going to do a lava lamp experiment. So we know reactions only occur until one of the reactants runs out. This is referred to as a limiting reactant. So we're going to be using some vegetable oil, Alka-Seltzer, food coloring, a container, and some water. So first, we're going to fill the bottle or this jar with 3/4 full with vegetable oil. Okay, here we go. Okay, this should be good. We're going to fill the rest of the jar with water. Almost to the top, we're going to give some space. Let some space here. Okay. And this should be good. Oh, we're not going to close it yet. So first, we know that oil and water do not mix, even if we try to shake it out with the jar. We see like they don't mix. Actually, we only see that the oil breaks up into small, tiny little drops, but it doesn't mix with the water, right? Oil and water don't mix because of how their molecules are constructed. Water is known as a polar molecule, and a water molecule is shaped like a V, like this, and with an O at the bottom and two hydrogens at the top, right, at the top ends. However, there is an unequal sharing of electrons between the hydrogen and oxygen atoms. This means that the bottom of the molecule has a negative electrical charge, while the two tops carry a positive charge. So the vegetable oil, on the other hand, is a nonpolar molecule made of long chains of hydrocarbon strings bonded with hydrogen 8 atom. Unlike the water molecule, there is a equal sharing of electrons between the carbon and the hydrogen atoms. This means that the electrical charge of the atoms are not separated. So the molecule don't have opposite and negative ends. So if we think of molecules like group of people is like water, a polar molecule, doesn't want to hang out with a non-polar molecule like oil. But for example, if like water will like to hang out with some polar molecule like food coloring, or like oil, a non-polar molecule will like to hang out with like another type of oil. Let's see, like olive oil, or like sesame seed oil, or car oil. Anyways, okay, let's go to the next step. Oh, also a fun fact. We see that the water is at the bottom and the oil at the top. This is because water is heavier than oil. Okay, let's keep with the experiment. We're going to add the food coloring. We're going to add about like 10 drops. See? Oh, it's close. Sorry for that. Okay, let's add this 4, 5, 6, 7, 8, 9, 10. Okay. As we can see here, the food coloring goes at the bottom with the water because they're kind of like the same group. They are polar molecule. Okay, now we have the Alka-Seltzer here. We're going to divide the Alka-Seltzer in small pieces. And okay, we're going to drop one of the pieces of the Alka-Seltzer into our oil and water mixture. Let's see what happens. Okay. Okay, we can see some bubbles here. Now we can see how the Alka-Seltzer is reacting. The Alka-Seltzer tablets react with the water to make tiny bubbles, as we can see over here. Tiny bubbles of carbon dioxide. The bubbles attach themselves to the blobs of colored water and cause them to float to the surface. And the whole thing starts over until the Alka-Seltzer is used up. So if we see that, we can like start our reaction again, adding more Alka-Seltzer tablets. And this is really cool. The reaction it will last like about 5 to 10 minutes per tablet, and we can keep the reaction just adding more Alka-Seltzers. Nice. This is so fun to watch. Let's just add the last piece of Alka-Seltzer tablet, and I'll just close my level lamp. And this is how you do the level lamp. Thank you.